Hello students, welcome back. Today is the seventh session of atomic structure, right? In our previous sessions, we had discussed about 18 electrons. Out of 118 electrons, you had around 18 to 20 electrons you had studied. I hope at this point of time, you know the 18 or 20 electrons up to calcium, you know, with their symbols, with the atomic number and with their atomic masses. So, if you know this much, then it is enough for you to go through this lesson, right? So, it is necessary, it's compulsory for you to remember the 20 elements, okay? 20 elements atomic number and 20 elements atomic masses. And their symbols. Symbols are very much important, students. Symbols, without symbols, we cannot learn chemistry. Okay, chemistry, to read the chemistry or to learn the chemistry, you should know the symbols. Okay, so in our previous sessions we had discussed about the number of 18 to 20 elements, and we had also studied about their valencies, and with that we also studied their electronic configuration. So electronic configuration is nothing but the distribution of electrons, wherein you studied K shell can accommodate 2, L shell 8 and L shell 8, M shell and 8. So it moves on like this up till 118 electrons. They accommodate the number of electrons. For your syllabus, up to 20 elements are there, and that much is enough for 8th standard. Okay. So in today's session, we will be learning more about valencies. Okay. Then let us see how it works for you. Then let us study valency. Before you could study valency, you need to know one more term that is called as valence electrons. Valence electrons. In valency, before you could study, we call it as valence electrons. So, valence electrons are those electrons which are present in the outermost shell of an element or any atom. Okay, valence electrons are those electrons, extra electrons, which are unable to become stable, which do not become stable. So those elements or those electrons, what they do, the extra electrons which are present in the outermost shell, that is what we call as valence electrons. Say for example, we have lithium. Okay, lithium atomic number is 3, symbol is Li. Okay, now see the electronic distribution now. Okay, so lithium 3 means K shell 2 electrons. Then L shell, only 1 electron, right? 3, atomic number is 3. So 1, 2, 3 electrons. K shell is filled, it moves to the next shell, that is L shell, 1 electron. Now in the outermost orbit or in the outermost shell, how many electrons are left? 1 electron is left. So therefore, to become stable, either the lithium will gain the electrons or it lose the electrons, depending upon its capacities. So therefore, we need 7 more electrons for lithium to get stable. That is 8 electrons to get filled. Here it needs 7 more electrons. Therefore, lithium, what it will do? It usually loses that electron. It loses this electron and perhaps gives to the one with which element needs it. So therefore, when it loses that electron, what does it becomes stable? Lithium becomes stable. So therefore, what happens here? Valence electron. How many valence electrons are there here? Extra electrons, that is 1. So 1 is the valence electron, and therefore if it loses or gains or shares and the number of extra electrons, that determines its valency. So how you define the valency now? Valency is nothing but it is the capacity. It is the capacity of an element or an atom to lose or to gain or to share the electrons. Okay, that is what we call it as valency. So number of electrons which are gained, lost or shared. Okay. Okay, sir. So we have, say for example now, let us say an element is there, and it has 1 valence electron. It has 1 valence electron. So let us say let us take any element which has 1 valence electron in its outermost shell. So that is lithium. Okay. So here when it loses electron, it becomes stable. So we are talking about the valency here. So here, then the electron is lost. So how many electrons is lost? One electron is lost. When one electron is lost, there comes a charge on it. That charge, we call it as a positive charge. So we call it as a positive charge. So it gains a positive charge. Okay. Similarly, if the element has got two valence electrons in its outermost shell, two electrons in its outermost shell. Now see here, this element, whichever the element it is, this element has got how many valence electrons? It has, here we have another element, so it has got two valence electrons. How many extra valence electrons are there here? Two valence electrons. So it needs 6 more electrons. Therefore, what this element will do? This element will, or this atom will lose that electrons. These 2 electrons are lost. So when 2 electrons are lost, there comes a charge on it, that is 2 plus. That is 2 plus. Okay. Similarly, if an atom has 3 valence electrons, has 3 valence electron, 1, 2, 3. So how many K shell 2 electron is filled here? So how many here 3 electrons are there? The atom needs how many electrons more? 5 more electrons. So it is better for an atom to gain that 5 electrons or to lose this 3 electrons. It is better for that atom to lose that 3 electrons. Therefore what it will do? This 3 atoms will be lost. So when 3 atoms, or sorry, the 3 electrons are lost, there comes a charge on that atom, that is what we call as 3 plus charge. Okay. So here all these 3 atoms, or all these 3 atoms, whichever the atoms are there here, all these 3 atoms have lost their electrons, and in out of 118 elements, there are 118 elements in our periodic table. Out of these 118 elements, all those elements which loses the electrons, we call them as what? We call them as metals. We call them as metals. And they have which charge? They have charge as electropositive charge. Electropositive charge. So always remember students, those elements or those atoms, okay, in elements atoms are present. In those atoms which loses the electrons whenever in atom the electrons are lost, there comes a charge on it, that is positive charge. They are electropositive. Now if I talk about 4 electrons here. So here we have, say, K shell is full. Okay, K shell is full. Now L shell, see here. Now L shell we have 4 electrons, 1, 2, 3 and 4. How many more electrons are required by this atom? It requires 4 more atoms or 4 more electrons. 1, 2, 3, 4 electrons are there. 4 more electrons that atom needs. So is it better for that atom to lose the electron or to gain the electron? It needs 4 more electrons, right? So therefore at this point of time, this atom, it can share. Yes, it can share. It can either take the electrons or it can lose the electrons. So therefore such atoms which shares the electrons, we call them as metalloids. So either it can share or it can lose. Okay, it can gain or it can lose. Such atoms or such elements we call them as metalloids. Such atoms or such atoms which share the electrons, we call them as metalloids. So either it can take the 4 electrons from the other atom, or it can, whatever the 4 electrons are there in its outermost shell, it can gain or lose. It can do both. So such atoms or which have both properties, we call them as metalloids. We call them as metalloids. So students, this was about electropositive. Like if the charge on them is positive, we call them as electropositive, and they are usually metals. Whereas if an electrons are shared, either it can gain or it can lose. In its outermost orbit, if 4 electrons are there, in K shell, in L shell 4 electrons are there, That is, it can gain or it can lose. Similarly, if in M shell 4 electrons are there, either it can gain or it can lose. So those elements we call them as metalloids. Okay. The next is, let's see, move on. Now if in the outermost shell, say an element is there, K shell 2 full, and we have 4 was there, now we have 5 electrons, 1, 2, 3, 4 and 5. How many more electrons are required by this atom? It requires 1, 2, 3, 4, 5. This means 3 more electrons are required here. So what this atom will do? Whether this atom will lose that 5 electrons or it will gain the 3 electrons. So it is better for that atom to gain. Here it is doing to gain. How many electrons it is gaining? 3 electrons it is gaining. When it is gaining 3 electrons, there comes a charge on it, that is 3 minus. That is, if it is gaining, the charge is minus. If it is losing, the charge is plus. It is reciprocal. Okay. Next we have another element. Say any element is there. So any element is there, and say in L shell 1, 2, 3, 4, 5 electrons are there. Say now we have 6 electrons. 1, 2, 3, 4, 5 and 6. So how many less is there? It has 2 less electrons. So what this atom will do? Will it give that 6 electrons to the another atom, or it gains the 2 electrons? Definitely it will gain the 2 electrons. So when it gains 2 electrons, there comes a charge on it, that is what we call as 2 minus. 2 minus charge. Similarly, if it is another atom which has K shell full and L shell, say it has 1, 2, 3, 4, 5, 6, 7. So in this atom it has 7 electrons. 7 electrons means this atom will either it will lose that 7 electrons or it will gain 1 electron. It is better for that atom to gain 1 electron. So when it is gaining, how many electrons it is gaining here? It is gaining 1 electron, and therefore the charge on it is 1 minus. Right. So all those elements among 118 elements, all those elements which are all gaining the electrons in K shell or L shell or M shell, all those electrons we call them as non-metals. We call them as non-metals. Always remember, students, those elements which gains the electron, they are non-metals, and all the elements which lose the electrons are metals. Okay. And also we call them as electropositive. Sorry, we call them as electronegative. Electropositive for metals and electronegative for non-metals. Okay. So this is it. Now see the last electron. So see the last element now. See, we have K shell full and L shell 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. This means this shell is full. Okay. This shell is full, and therefore, so this is a K shell is full, and therefore it is what? Completely full. It neither gains the electron nor it loses the electron. It is a highly stable atom. Now tell me, such you can know, you might know this at this point of time, and you know which atom is this which has completely full K shell and L shell. That is neon. That is neon. Neon is the element which has K shell and L shell full, who has atomic number 10, right? So therefore, we have K shell and L shell full, neither it gains the electron nor it loses the electron. It is a highly stable and a very rare element. These are called as what? They are noble gases. They are noble gases or inert gases. They are noble gases or inert gases which have their shells completely full. They do not react with any other, because they have completely filled shells. They don't need the electrons nor they lose the electrons. Therefore, they do not react and they are highly stable. Whereas in metals and non-metals, So this way you will come to know if the elements in the atoms, elements or atoms, when they loses the electron, they form a charge on it. We call them as electropositive, and they are usually metals. And those atoms which gains the electrons and they are non-metals and the charge on them is electronegative. Whereas those elements which share the electrons, usually in their outermost orbit K, that is in L shell or M shell or in N shell, four electrons are there. At that point of time we call them as metalloids. They have both intermediate properties, metals, and that were non-metals. And the last one is noble gases, which has completely filled orbit, and they have K shell, L shell, all shells are full. In, say for you, like the second first inert gas or and the first stable element is in our periodic table is helium. It is after hydrogen, helium is the element which is stable. Then comes neon, right? In a like this, number of elements will be there who has number of shells completely filled. Okay students, now the valency is broadly classified depending upon this explanation. We will divide this valency into two main categories. Okay, valency based on the previous discussion, we will divide them broadly into, valency can be divided broadly into two types. One is what we call as electrovalency. We call them as electrovalency. Electrovalency. Okay. The another one is covalency. Electrovalency and covalency. So, in those atoms which have gained or which have lost the electrons to attain the noble gas electronic configuration, that is to become stable. Why these electrons will gain or lose? To become stable, like helium, like neon, to completely that their shell should be full, that is full. If they have some extra electrons in their orbits, either they will lose the electrons or they will gain the electrons. So at that point of time, how we define the electrovalency? Electrovalency is a valency when electrons, what they do, either they will lose or they will gain the electrons in their outermost orbit to become stable or to attain the noble gas electronic configuration, that is 288, that is electronic configuration. To attain that, what they will do, they will either gain the electrons or they will lose the electrons. So such electrons or such atoms, we call them as such valency we call them as electrovalency. Electrovalency can be further divided into positive electrovalency and negative electrovalency. Usually electrovalency has what? When they gain, what happens? When they gain, what happens? They become negative. And when they lose, they become positive, right? So that only we are dividing here as positive electrovalency and negative electrovalency. Positive electrovalency and negative electrovalency. So here, how do you define the positive electrovalency? All those metals, they are, whenever they lost the electrons, they attained the positive charge on them, right? They became positive. So all those metals which have lost their electrons are what? They have a valency called electropositive valency. We call them as electropositive valency. So here we say that electropositive are those elements which have positive valency, Na plus, right? When they have positive valency. Similarly, 2 plus, magnesium has 2 plus, and we have aluminium 3 plus, right? All those atoms which have positive valency, we call them as electropositive, or else you can call them as positive electrovalency. Whenever they gain, whenever they lose the electron, there comes a charge on them, and we call them as positive electrovalency. Electronegative valency has one more type, what is we call as negative valency. Negative valency is a valency wherein all the elements which have, we can say which have here gained the electrons, they need the electrons, they have gained the electrons, those elements we call them as, whenever we call them as negative electrovalency. There comes a charge on them and that determines its valency, and therefore we call it as negative electrovalency. For example, we have chlorine 1 minus, then we have oxygen 2 minus, say nitrogen 3 minus. This determines its valency. So this is about electrovalency, positive electrovalency and negative electrovalency. So let me explain this further. Sodium. Okay. So here sodium has an atomic number 11. Sodium has electronic number 11. See now, let us see the electronic configuration. K shell 2 electrons, L shell 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. 2, 8 is 10 electrons. So in K full, L full. Now M is 1 electron. How many valence electron is there? 1 valence electron is there. Therefore, what this sodium will do? This sodium will lose that 1 electron. How many electrons it has been lost? 1 electron has been lost. So, 1 electron is lost. There comes a charge on it and the valency is what? Plus 1. Valency is plus 1. That is what we call as positive electrovalency. Okay, similarly we have here number of examples for negative electrovalency. Now let me take this example, oxygen. Oxygen has atomic number 8. This means in K shell 2 electrons, in L shell how many electrons? 1, 2, 3, 4, 5, 6. 6 electrons, 2 here, 6 here, 8 electrons. How many electrons oxygen more needs to become stable? It needs 2 more electrons. So what oxygen will do? Instead of losing that 6 electrons, it will gain. It will gain. How many electrons it has been gained? 2 electrons it has gained. Therefore, it attains a charge on it, that is 2 minus when it gains. Therefore, valency is what? Valency is negative. When it is gaining, valency is negative. How many determine negative valence? Determines the number of electrons it has gained. That determines its valency and positivity or negativity. Here it has gained 2 electrons. The valency is 2 minus. Here it has lost the 1 electron. The valency is 1 plus. It has lost plus, valency is plus. If it has gained, valency is minus. Okay, this is what we call as electrovalency. Next we have another type of valency, that is what is covalency. Covalency is a valency in which the electrons are shared. It is less like, you know students, if you have given me the 2 chocolates, I am giving you the 2 chocolates back. It is like that. Okay, covalency is nothing but if an atom or if an atom has shared, the word shared, we always remember in covalency, sharing of electrons. Sharing of electrons. Sharing of electrons in the sense, if an atom has shared 2 electrons, in return that another atom will also share the 2 electrons. That is what we call as covalency. If an atom has shared 1 electron, another atom will also share 1 electron. That is sharing. Equal number of electrons will be shared. Now see, for example, I will tell you. Let us define it first. It is the number of electrons, this is the number of electrons shared by an atom of an element to achieve the nearest electronic configuration. We call them it as covalency. Now see here, we have H2O. H2O. So hydrogen atomic number. So students, you should know the symbols, you should know the atomic number. So hydrogen atomic number is 1. Okay, so it has only 1 electron in its K shell. Okay, now oxygen atomic number is 8. So K shell 2 electrons, here 6 electrons, 1, 2, 3, 4, 5, 6. Okay, but here we have Hydrogen needs one more electron to completely fill its octet, and therefore oxygen has 8 electrons, it needs 2 more electrons in its K shell to get complete its octet. So therefore what we'll do, 2 atoms of hydrogen, here I will, oxygen, this is the oxygen, okay. So here what it will do, it has 6 electrons in its outermost orbit, it has 6 electrons, see, 1, 2, 3, 4, 5, 6, that is I am representing here. Okay, now hydrogen has how many electrons? Hydrogen has one electron. If oxygen shares one electron with hydrogen, then this another hydrogen will share its one more electron. Therefore, oxygen will also get one electron from one hydrogen, and hydrogen also will get one electron to become stable. So this way, the hydrogen, if hydrogen shares one electron with oxygen, the shell, hydrogen becomes stable. Similarly, if this hydrogen atom also shares its one atom, then this atom will become stable. If both hydrogen has shared one electron, then this oxygen also will have to share the 2 electrons. So oxygen also needs 2 electrons. Therefore, this also oxygen becomes stable due to the covalency. This is how the water has formed. Okay, sharing of electrons. Similarly, one more example I will give you, NH3. Ammonia. So the atomic number of nitrogen is 7, hydrogen is 3. So in K shell, outermost orbit, how many electrons should be there? 1, 2, 3, 4, 5, 6 and 7. So here 1, 2, 3, 4, 5. How many more electrons are needed? 3 more electrons are needed. That 3 electrons which have been less in nitrogen, that will be shared by 3 atoms of hydrogen. So what hydrogen is having one electron. If hydrogen, one atom of hydrogen shares its one electron with the nitrogen, what happens? It becomes stable. So this is how it works in covalency. Covalency is nothing but the number of electrons are shared in equal numbers. If an atom has shared one electron, another atom also will share one electron. So if an atom has shared 2 electrons, another atom will also share its 2 electrons to become what? To become stable. To attain the nearest electronic configuration, these atoms will share the electrons, that is what we call as covalency. Okay students? Okay students, now the worksheet given in page number 71. Okay, there is a table given here, valence electrons 1, 2, 3, 4, that is in the extra electrons which are present, it is 1, 2, 3 up to 8 electrons they have given in the outermost orbit, last orbit, whichever the last orbit is there for a given element on an atom, that would determine its valency. That is, so if the valence electron is none, then what would be the valency here? Valency would be +1 because it needs, it is gaining here. So it is losing here. When the valency is 1, it will lose 1. So therefore, if the valence electron is 2, it is losing that 2 electrons because it needs 6 more electrons. Similarly, if the 3 are the valence electron, it will lose that 3 electrons. Okay, so 3. 4 means neither it will gain nor it will lose. Neither it will gain nor it will, that is, it can gain also nor it can lose also. So that is metalloid. It has a property of metalloid. So 5 electrons are there in the valence electron. It is better to gain. So if it is gaining, the charge on it is, valency would be what? -3, because it is gaining. How many electrons it is gaining? It is gaining 3 more electrons. Similarly, in its outermost orbit, 6 electrons are there. It is gaining 2 electrons. So the -2. And if it has 7 electrons, instead of giving 7 electrons, it will take 1 electron or it will gain 1 electron, and therefore the charge on it is -1. Valency is -1. Whereas if it has completely filled shell, 8 electrons are there in its shell, and the valency is what? 0. All those elements which have positive charge or positive valency, you can say, all those elements which have positive valency, all are what? All are metals. All are metals. All are metals. And those elements which can either gain or it can lose, we call them as metalloid. and all those atoms which have property or negative valency, which have electronegative or which have negative valency on them, that is a negative charge on them, we call them as non-metals. We call them as non-metals. And whereas the last one, which has got 8 electrons, that completely filled shell, we call them as inert gas or noble gas. Inert gas or noble gas, which are highly stable, which are highly unreactive metal or unreactive element, you can say. Okay, so therefore this is the highly, which has K shell, that is L shell, M shell is completely filled and it do not react because its shells are full. Okay, so this is about the worksheet. Okay students, now homework for you. Complete this table in your homework book, as well as try to solve that worksheet which is given in your textbook. It is given in page number 71, and therefore we will discuss about these in our next session. Okay, thank you.